Hey everyone, Dr. Dan here, and this is for week 13 of History 3380. And this week we're going to talk about R&D, also known as research and development. And it kind of makes sense because we've been going through this idea of creative destruction. So last week we talked about creative destruction, which really was this idea that businesses, products, technologies become obsolete. In other words, there's always something else that comes along to obsolete what exists. And in the context of business and technology in American history, it's important to understand how research and development leads to new innovations and how in turn these new innovations are related to this notion of creative destruction. So again, obsolescence in our own lives is pretty easy to think about. A lot of us grew up with landline phones in our house, and now most homes don't have landline phones anymore because we all use our cell phones. So this idea of the old telephone being eclipsed by the cell phone is a great example of creative destruction. And there are many more. If you go way back, the typewriter being replaced by the computer and the word processor, the desktop computer slowly being replaced by mobile devices such as iPads. We see these cycles go on again and again and again and again. So creative destruction is really related to this idea of innovation and invention. So how does that happen? Typically that happens through research and development. And there's a couple of articles you have to read this week, and there's the online text, and it talks about research and development in the context of really three different forms. So the classic form is the research and development department at a large corporation. So one of the first R&D departments that was related to a company was that of Thomas Edison's, and there's a link to Rutgers University in this week's reading and an archive about Edison's invention factory in Menlo Park, New Jersey. So that's one of the earliest pure R&D plays is Edison's lab in New Jersey, and that's in the late 1800s. And again, what Edison did was he set up a building, a dedicated space with scientific equipment, machine shop, anything he needed to carry out his inventions. And then he had people that he hired just to work on inventions and inventing and innovations. So Edison's one of the first examples. Procter and Gamble in Cincinnati had an R&D lab early on, and then some of the other ones just mentioned in the article, not in any detail. General Electric, of course, DuPont, AT&T, Kodak had a big R&D arm. IBM, all of these large corporations have research and development departments. And really, when you think about the innovations and inventions and new businesses from the past compared to now, there's a big difference. So if you think about Edison for a second, what he's inventing mostly are things that are electrical in nature. So whether it be the light bulb, which he's famous for, or the phonograph, or generators to generate electricity, these were all tangible devices that needed machining and needed to be built by engineers. So the classic R&D lab from the past was developing these big inventions, these big physical things. So that really needed laboratory space and in some cases a lot of chemistry lab space, that sort of thing. So if you think of Kodak R&D, one of the things invented out of the Kodak R&D lab was color motion picture film. So again, that took a laboratory and processes and scientists that knew what they were doing to develop it. And it's the same when you look at like pharmaceuticals today. Pharmaceuticals, have to have these big labs with a lot of scientists because their work is capital intensive. It's a lot of trial and error, and it needs to be done in a controlled lab environment. So it takes up a lot of space. It's very expensive to do that research. It's very time consuming. So this private R&D is one aspect of what you need to know about this week, that that these companies with these big inventions, IBM, Edison, Kodak, whatever, they had these R&D labs, and that's where their future products came from. So it was worth it to them to invest in R&D. The sort of second phase of R&D, or actually it's not really a phase, it's something that runs parallel in American history, is federally funded research. So if you look at the Department of Defense, for example, obviously they did a lot of research into something like the atomic bomb with the Manhattan Project, Los Alamos Labs. Those are all big federal labs, and in a lot of cases, federal research is funded through grants to universities. So we have this idea of corporate R&D, and we have this idea of federally funded research and development, ranging from independent government-owned laboratories like Los Alamos, or like the Springfield Armory that we talked about when we talked about the American system of manufacturing. Those were government-run labs, and then also government-funded research through universities or government grants, which still goes on today. And there's an article you need to read this week about federally funded research. And, it's really interesting when you go through the article, all of the things, breakthrough technologies that came out of federally funded research. So the internet, of course, is the most famous one that started with the ARPANET, which was a Department of Defense initiative. Another one was magnetic resonance imaging, so MRI. Many of you have had MRIs to diagnose medical issues. MRIs all came out of federally funded research, and the list goes on. And there's a decent article that goes through all of these federal funded innovations. So like closed captioning is another one that came out of federally funded research. Speech recognition. There's a number of them, and so it's important to understand that the federal government does fund research. And then sort of the third part of the reading this week talks about all of the big inventions or big innovations that basically didn't come out of a university officially, or they didn't come out of a corporate lab, but they came out of someone's garage, or they came out of someone's dorm room. And one of the reasons it's kind of shifting and changing is because the products and innovations that have a lot of value right now are generally software related, and you don't need a big lab to write code. So when you think about Bill Gates basically writing the first MS-DOS system in his dorm room, you think about Facebook and Mark Zuckerberg in his dorm room. You think about Michael Dell starting Dell Computer in his dorm room at the University of Texas. The nature of what has value now has changed. So therefore, these giant, really expensive R&D labs aren't as much of a necessity as they used to be. Now, that having been said, on the reading this week, you'll look at the top 10 research and development spenders, and Amazon, Google, Intel, Microsoft all still have these giant R&D departments. But the reason they do is because those companies are all making a lot of money, and when a company is profitable, generally you can afford to do this forward research, and it makes sense because the more forward research you do, the better off you are down the road. And as you do the readings this week, one of the things you'll learn is that American corporations and also the federal government, they have really cut back on R&D spending because it's one of the first things to go when either the national economy is poor or when a corporation's profitability is poor. So someone like Amazon and Google and Microsoft and Intel, they can afford to do a lot of R&D, whereas other old hardline companies have really cut back their R&D, with the exception of the pharmaceutical industry, because it's just the nature of the beast that you have to have big labs to develop cutting-edge pharmaceuticals. So I just want you to understand that innovation, invention comes through a lot of different channels, and the way that fits in with the history of business and technology is, if we're going to understand creative destruction, we have to understand how new products are developed and how eventually they get sent to market. So that's a thing that you need to understand. The other thing is, make a note, in the federally funded Projects article that the United States is really still a leader in funded R&D, but we're really lagging behind to China, and there's a lagging effect when this happens. So R&D really, the R&D we're doing today, the research and development we're doing today, might not manifest itself in anything useful for 10, 20, 30, 40 years down the road. So the fact that we're cutting back federally funded research and development right now in a lot of important areas means that down the road, the U.S. May lose its edge in innovations, and other countries like China, which are federally funding a lot of research, they're going to gain down the road as far as where the latest innovations come from. So it's just something to be aware of, something to pay attention to, and I think you'll find. I think you'll find it interesting, especially as we get into our next module, which is going to feature a gentleman named Robert Noyce, who is really the inventor of the integrated circuit. And there's going to be a movie or a documentary you're going to watch about Robert Noyce next week. And it will demonstrate to you how an invention or an innovation like the integrated circuit really totally changed the world. So that's it for this week. Learn about R&D. Make sure you read those articles. There's also a video link to a video featuring Jeff Bezos, the founder of Amazon. That link is found within the reading. And go ahead and watch Bezos too, because he talks about the importance of invention and innovation at Amazon. So that's it for this week. Stay safe, be well, take care. Bye-bye.